Welcome to my channel, viewers and all the dear students. And see, here is the some standard limit, and that is number 1 and 2. Here we want to prove here, and this is the standard from limit x tends to a, x to the power n minus a to the power n by x minus a, that is equal to n into a to the power n minus 1, where n is a rational number. And number 2 is their limit sin x by x equal to 1, where x is the measure in radians. Okay, for this type of proof I want to use the two formulas. Number 1, see, x plus a whole to the power n, that is a plus x whole to the power n, that is nc0 a to the power n, nc1 a to the power n minus 1 into x to the power 1, nc2 into a to the power n minus 2 and x to the power 2, plus nc3 a to the power n minus 3 into x to the power 3, plus ncn a to the power n minus n into x to the power n, when n is a positive integer, but it is then given that there is a rational number. It may be a fraction or integer. Okay, when it is a fraction or then it tends to be a not an ending term here, so not needed to the written in ending terms. Now see, for question number 1, here is limit x tends to a and x to the power n minus a to the power n by x minus a. Let y is equal to x minus a, as x tends to a, therefore y tends to 0. Therefore this is equal to limit y tends to 0, and this is here in place of x we put here a plus y whole to the power n minus a to the power n by y. And this is equal to y tends to 0, and from the binomial theorem we can express as nc0 either that is a to the power n. If it is an nc1, we can write here n a to the power n minus 1 into x to the power 1, and it is nc2, so this is nc2, so we can write here n minus 1 by factorial 2 and a to the power n minus 2 and x to the power 2 plus dot dot dot. Okay, and minus here is a to the power n by y, so these two terms are cancelled, so this is equal to limit y tends to 0, and actually this is here y, we wrongly written as a x here, so it would be a y. So taken common y here, so n into a to the power n minus 1, so n into n minus 1 by 2 into a to the power n minus 2, as we taken common y here, here is degree 2, so we can write here y, so this is the okay, and whole divided by y, so y are cancelled, since y tends to 0, y never be 0, so therefore put y in place of y as a 0, so you got here n into a to the power n minus 1 plus 0 plus 0 plus 0, so therefore only a into n into a to the power n minus 1. This is the first formula is proved. So this is your question number 1. So this is limit x tends to a and x to the power n minus x to the power n a minus a to the power n by x minus a, and that is n into a to the power n minus 1. Okay, now next formula for need to know the sine series for 2. So we can write sin x is equal to x minus sin x is equal to x minus x square by factorial 3, and sorry, this is cube, x cube by factorial 3, x to the 5 by factorial 5, and this is the sine series. Okay, therefore limit x tends to 0, sin x by x, and this is equal to limit x tends to 0. Now we write here sine series. This is x minus x cube by factorial 3, x to the 5 by factorial 5, okay, and whole divided by x, and that is equal to limit x tends to 0. Take common x within the first bracket. So then we have 1 within the third bracket, 1 minus x square by factorial 3, x to the power 4 by factorial 5, dot to infinity, and this is whole divided by x. So these two are cancelled. Since x tends to 0, x not equal to 0. Therefore, put in place of s which is approach to 0. So that's why 1 minus 0 by 3 and 0 by factorial 5 factorial 3, okay, like that. So all the next term are 0, so we get here only 1. Okay, and this is the standard formula. Limit x tends to 0, sin x by x is 1. Okay, see, next formula third number, limit x tends to 0, e to the power x minus 1 by x, okay, and that is equal to 1. We have to show this is equal to 1 for E series. So exponential series e to the power x is equal to 1 plus x by factorial 1, x square by factorial 2, x cube by factorial 3, dot to infinity. Therefore, limit x tends to 0, e to the power x minus 1 by x. So this is equal to limit x approach to 0. Okay, in place of e to the power x we put the series 1 plus x by factorial 1 x square by factorial 2, so dot dot to infinity, and this is here minus 1 by x, so 1 are cancelled, so therefore limit x tends to 0. Take common x, so 1 here, and x by factorial 2 x square by factorial 3 and divide by x, so x cancel since x approach to 0, so x never equal to 0. Okay, so now put x approach to 0 to the remaining part, so 1 plus 0 plus 0, so we got here only 1. This is answer. Now next standard formula is here. Question number formula number 4. If n is a rational number, limit x approach to 0, 1 plus x whole to the power n minus 1 by x, and that is equal to n when n is a rational number. Okay, now we use the binomial theorem. If we expand this is here 1, nc1 actually n by factorial 1 into x, n into n minus 1 by factorial 2 into x square dot dot to infinity, and this is minus 1 by x. Okay, actually this value does not depend on the ending term, as we take a common x and then x approach to 0, so the remaining all the term where x are belongs, so that's why. Okay, now 1 are cancelled, so now limit x tends to 0, then we take common x, then here n into n minus 1 by 2 into x and dot dot dot. Okay, C of this expansion except first term, the remaining all the term are exist x. Okay, so these x are cancelled, so as x approach to 0, so x never will be equal to 0. Now see, if we put 0 approach to 0 to the each term, then only we have left here n, so this is your answer. Okay, so question number 5. Limit x tends to 0, log to the base e, 1 plus x by x is equal to 1. Now the logarithm says 1 plus x to the base e equal to x minus x square by 2 and x cube by 3. Okay, dot dot to infinity. Now therefore limit x tends to 0, log to the base e 1 plus x by x, and that is equal to limit x tends to 0. This is here x minus x square by 2 x to the cube by 3 dot to infinity by x. Limit x tends to 0, take common x, then here is 1, here is x by 2, here is x squared by 3 all divided by x. These x are cancelled, same x tends to 0, x not equal to 0. Okay, so therefore put x approach to 0 to the each term, so we get here only 1. Limit x tends to 0, 1 plus x to the power 1 by x. Actually this is equal to e. Okay, you know, for a we can write e to the power log a to the base e. Okay, so limit x tends to 0, 1 plus x to the power 1 by x, and that is limit x tends to 0, e to the power log to the base e 1 plus x to the power 1 by x, and that is equal to limit as x approaches to 0, so e to the power 1 by x and log of 1 plus x. Okay, and now in previous proof we have to show that the value of the limit is 1 when x is approach to 0. Okay, so that is e to the power limit x tends to 0 and log of 1 plus x and whole divided by x, that is e to the power 1. Actually this is equal to e. And this is here 6 point. Okay, 6. Now here is 7, that is limit x tends to 0, a to the power x minus 1 by x. Okay, it can be also written as like limit x tends to 0, and this is e to the power logarithm, general logarithm of a to the power x minus 1 by x, and this is equal to limit x tends to 0, this is your x e to the power x log a to the base c minus 1. Okay, and this is equal to the expansion of e series, and that is 1 plus x general logarithm of a to the base e and whole divided by 1 x log a to the base e, and this is your whole square by factorial 2. Okay, this is your minus 1 and whole divided by x, so 1 are cancelled. So limit x tends to 0, take common x to the east term, so this is x log a to the base e whole square by factorial 2 by factorial 1 dot to infinity by x. So x cancel since x approach to 0, so x never be 0. Now put here in the east term, which is x approach to 0, then we get only log a to the base e. So this is your answer. When a is more than 0. Okay, this is a very important point, dear student. I hope you all understood my class. So if you enjoy the class, then share this video to your friends and don't forget to subscribe my channel. Okay, thank you.